Assalamualaikum warahmatullahi wabarakatuh. In this video, I will demonstrate a calculation of simple stoichiometry can be so easy by using an application from Microsoft Excel. Okay, let's start. Let's open the application. First of all, thank you for like, share, and subscribe. Alright, I will explain the features of this application and how it works. Basically, we only need to input an imbalanced chemical reaction or unbalanced chemical reaction in the yellow box. The left side is for reactants and the right side is for product. Alright, the basic rules, how to input the chemical reaction in this application. We have to use the plus sign. It is used as separation between each compound. Yeah, example, H2H5 plus O2 like that. Alright, there are maximum 10 compound in the reactants can be recognized by the application, and also 10 compound of products. Okay, application will automatically calculate the coefficient of each compound and it will be shown in the green box here, and also in details and calculation table below. Okay, let's try. We can type example iron oxide plus phosphoric acid, alright, the reactant, and the product iron phosphate and plus water. Alright, after this, don't forget to hit enter keys. Don't click, don't click another cell, but hit enter. Don't forget to hit enter. Yes, until this confirmation has come out. New stoichiometry equation detected. Do you want to erase previous data? If we click OK, if we input previous data in previous chemical reaction, it will be deleted or cancel. It still we have data, previous data. Alright, if we see here, this is the balance chemical reaction. So now, okay, we click OK. Yeah, it takes time, but I think less than a minute. Okay, new balance reaction. Previous inputs have been cleared. Okay, this means, yeah, we can see here in the details and calculation and the product. Alright, and the reactant. This is the composition of all elements in the reactant and the total element, and this is the product, and this is the remark. There's the it is balanced, and this is automatically from the gray box become the yellow box. Yellow box means we can input manually. This is for the product expected data, and this is for the reactants. We can see here there's a radio button. We can choose either calculation for reaction stoichiometry. This is I think for the ideal ratio, coefficient moles ratio, and this is for calculation for limiting reagent. Alright, that's right. The calculation it show that iron oxide needs 3 moles to be reacted with the iron phosphate is 2 moles. But how about 1.6 mole? You can click and enter. Calculation of balance reaction will be processed for actual data. Alright, calculation of stoichiometry has been updated. Alright, if we have a 1.6 moles of iron oxide, then the phosphoric acid, uh, yeah, it 1.066666, right? And the product, yeah, iron phosphate, it it produced 0.5333 moles, or around 190.65 gram. Okay, we can change. If we expected the water around 50 grams, we can change the data. Just hit enter like this. The percent of balance will be processed. Okay, the system is recalculated, and that's the result. We expect the water is about 50 grams, and uh, yeah, it calculated we need around 199.4 iron oxide to be reacted with 181.3 phosphoric acid. Okay. And another example, if we want to calculating the limiting reagent, if we have the availability of iron oxide and phosphoric acid, okay, we can try. Alright, there's a guideline for limiting reagent calculation. Please fill one data only, either moles or mass, for each reactant compound in each column. Then system will calculate automatically. Okay, we have to choose. We we can input moles here or here in the mass gram. But in each column, we have to fill at least one data. For example, if we just type here, alright, that's alert. This input number decimal in the yellow box only. This is the validation from the Microsoft Excel. And please choose one input, either moles or mass in one column. And to start over the calculation of limiting reagent, please delete content in all yellow boxes. No, cannot input alphabet or words. Uh, we can try. We input 6 moles and 67 grams. No, the calculation is error. This is error. Okay, cancel. Okay, we can input 6 in moles, or we can delete and we change. It is about 67 grams of iron oxide. And if we have a 0.4 of phosphoric acid, and we hit enter. Yeah, the limiting reagent calculation will be processed. Click OK. Alright, with this composition, calculation of limiting reagent has been updated. With this composition, the calculation show us that phosphoric acid will be the limiting reagent because the percentage of usage is 100%, and the iron oxide will excess, and the remaining is about 0.3 moles, or about 23.89 grams, only 64.34%. And how about the end product? Let's see, the water produced is 0.6 mole, or around 10.809 grams. But if the actual only 9 grams, we can enter. The mass of water is only 9 grams, and it means the percent yield of this reaction is 83.26%, or around 72 870 grams means the iron phosphate percent yield is 97.91%. Right, that's a sample we can try. And this is the important thing is the application can detect and calculate by an algorithm of matrix calculation. Alright, before we continue, I'll show you that there's another sheets here. We can use this as a concentration calculator. Molarity, this is input equal to molarity to m, and the volume is 2 liters, and the mole is 4. Yeah, you can choose which data we have and what uh, output we expect. Alright. And the other thing is ideal gas calculator. This is based on the formula PV equal nRT. This is the legend. P for pressure, V for volume, N is mole, R is constant number, and T for temperature. And we can choose the units also. This is for pressure, atm bar, Pascal per millimeter mercury. And this is the output. The output is we can choose the units also like liter or cubic meter and ppm, but not moles, no. And molar mass is standard unit. 1 atm, but 200 verified. Okay, the answer is 150. Alright, back to the main sheet. But let's continue with another equation. I have downloaded from the internet the imbalance list of imbalance chemical reaction here. Yeah, we can choose. This is to function test our application here. Okay. Yeah, we can choose. This is the second method. It's not typing, but copy paste. Don't forget to hit enter. Okay. I'll try to click cancel. And we'll see. Yeah, data from previous reaction are not deleted. Please be aware. You see this? This is data from previous equation. Means this is the iron oxide, ferrum oxide, iron oxide previous, and they say this. This is the previous. Careful. This is not the final answer of this equation because we click cancel, and this is the reactant and product element. Alright, try this sampling. Okay, don't forget to hit enter. Yeah, we click cancel. This is faster than if we click OK. Alright, this is the balanced chemical reaction as an output. I'll show you if we add some element or compound Rx example. Okay, system detect as Rx, but it is unknown compound. The gray box did not change to yellow box. Nothing happened. Also, if we have in the middle example is dx. What is dx? Okay, enter and cancel. And the product, yeah, and the product is dx, like here, dx dx, and dx, but still unknown compound. What is dx? No. We see this, hit enter, and the unknown compound is ignored by the system. Still one, one, two, two, one, 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 one. Alright, this will show you. Alright, that's this is a long chemical reaction. Let's try. Alright, hit enter and cancel. Alright, we see here this is the ideal ratio of the coefficient from this equation we input or copy paste here. The special things in here, this is the yeah this is detected as one compound here, and the number in the front of MOO3 here is not ignored, it's calculated, except we have example 19 water. This is ignored by the system, and the answer is still 12 moles of H2O. No matter how we input this is ignored, right? But if the number, this is for this format dot 12 MOO3. This means the MO is 12 in the product. You can see here. It is calculated. So the answer should be the coefficient must be balanced, and the coefficient of this compound is 12. Right? But if like this is different thing. Yeah, enter. Sorry, until right, cancel. Yeah, the equation of balanced chemical reactions change. There is 7 here, 12, 3. So it's changed. And this is separated. It's detected as two compound. Yeah, but if you are chemical engineer, you know the difference, right? Just 12. Alright, this is become one compound. On the product is only 3 compound. 1, 2, and 3. Let me change this. 7, for example. Enter. Alright, cancel. Alright, and the calculation is different, right? Alright, let's back to the for this question. Alright, we try this. If the system can solve this chemical equation, then our application is function well. Right. Oh, this is difficult to calculate manually. The coefficient is 10, 122, potassium permanganate, and 299 uh, hydro acid, sulfuric acid, and product is 162 potassium sulfate. Alright, Alright, I think this is the last one. We'll try this. Hit enter. Alright. Yeah, the system can also calculate it. I think, yeah, it's a simple stoichiometry, but it's a long equation with uh, three three compound of reactants, and the product is six compound product. Yeah, we can try this. Assume that it's 5 moles. Enter. Alright, calculation is as show. Yeah, limiting region. Alright, this is because we click cancel this from previous data. It wasn't delayed. Okay, we delete first. There's 3 reactants. Okay, we try this. 1 mole, 16, and 58. 58 moles. Okay, enter. Alright, this is the ideal composition, ideal coefficient ratio, moles ratio 1, 16, and 58. And all compound here will become limiting region because this is perfect composition. But if we change, alright, sorry, we have to delete first. 0.9, this is 15, and this is 56. Alright, the ratio I think is not ideal. And for this composition, yeah, this compound is as acting as limiting reagent because the percentage of usage is 100% and the other is only 96% and 93.21%, and the remaining in the remark is, yeah, for this compound 0.6 mole or equivalent with 157.18 grams. Yeah, we can change whatever we want. Alright, I think we can uh, try with another. This is a very okay. I will show you. I have opened the internet. This is for the, from www.camschool.net, and this is the question, problem question. Okay, we can try our application. Okay, this is the boric acid or boric acid. Okay, boric acid is react and produce. I think this is the colemanite or pyrophosphoric acid. I think it's colemanite and water. Hit enter. I think it is okay. Start. Okay, longer than. Alright, this is the ideal coefficient moles ratio product. Okay, what is the question? If 4.5754 moles of this reactant reacted how many grams? Question is grams of this colemanite product here will be produced. Right, 4.5754. All right, yeah. moles. I think 4.5754. Right, enter. And the question is how many grams? Okay, how many grams of this? Alright, the answer is 186.7426. I think we can round up. Okay, answer here. Type here 186.75 grams. Right, we continue. Okay, the second problem. Okay, hit enter. I think we just cancel. It's faster. Okay, but please be aware, right? And what is the question? 349.12 grams of this reactant. And how many moles of water? Alright, moles, grams and moles. 6 grams, the known number is gram. 3.300. Alright, check again. 349.12. Yes, hit enter. And the question is water, moles of water. Wait for a while. Alright. And this is the output 1.7813335554. Alright. Okay. 1.7813. Okay. Let's continue. Okay, for the third problem, this is zinc react with chloride acid, and the product is zinc chloride plus hydrogen H2. Enter. I think this answer. Okay, the question is if 2.8555 moles of this product H2 as product, and the question is also the product, but grams of this product, right? 2.555. Okay, so we have to go down, and from this area, this is product area. The question, the known data is the product, and the other product is question. Yeah, 2.8 moles H2. Sorry. Alright. 2.85, wait, 555 H2, and the question is this zinc chloride grams. Okay, hit enter. Okay, wait for a while. Okay, that's an answer. 389.19. Yeah, yeah, if we round up, it's 0.20, 389. Right. 389.20 grams. Alright, fourth problems. This is the lead nitrate react with potassium chromate, and there's a bird sound in my house. Alright, and the product is lead chromate plus potassium nitrate. Okay, hit enter. I click cancel. Okay, what is the question? Moles of potassium chromate here 1.0655 and react with lead nitrate. Oh, I think this is the limiting reagent question. Okay, 1.0655 moles, and be careful, this is for the second reactant and this is the first. Alright, so we need to click this radio button. Okay, the question is the known data is moles and moles. Oh, this is lead nitrate, that is 0.655. This is 3.032. 3.032. Okay, hit enter and the limiting reagent calculation will be processed. Okay, with its composition, the lead nitrate is a limiting reagent and it is only 35. Alright, the question is potassium nitrate. How many moles? How many moles of potassium nitrate? And the answer is 2.131 moles. 2.131. Two, sorry, 2.131 moles of potassium nitrate. And the fifth, I think this is the last problem today. Right? This is the titanium tetrachloride react with magnesium and product is titanium and magnesium chloride. Enter, cancel, and what is the question? Oh, 1.3546. The question is okay. I think we have to, yeah. Here 13546 more. And the question is the magnesium. Alright, let's see, this is the answer. Okay, and this is the answer 2.7092. 2.7092. Okay, okay, the whole 5 questions, 5 problems we have answered. So we check. Okay. Yeah, we have score 5 out of 5, 100% good, but this is a remark. Your answer should have 5 feet. Okay, we should add 1. Oh, I think 0 and 0. Okay. Correct, 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 and correct. Alright, so that's it. And our application here is function well. We have tried, and you can yeah, tell your comments, and this is my email. Alright, that's all. Thanks for watching. Wassalamualaikum warahmatullahi wabarakatuh.